All right, guys, our last lesson for week 1 is going to be lesson 3, which is writing equations from data. Okay, so our first lesson we learned what is a linear function, what is slope, what's a y-intercept. In our second lesson, we talked about how to graph them if you're given an equation. Today, I'm going to show you guys how you can find the equation of a straight line when you have a graph or just some data, and we'll even look at how to do the same thing with a word problem. So that's our lesson for today, is to how do you write the equation of a line if you have a graph, 2 points, or a word problem. So let's go ahead and jump in here. So linear function, you guys don't need to write this. You already have this in your notes. But you know, linear function is y equals mx plus b. The x's and y's in this equation represent all the points that exist for that equation, x comma y. The m represents the rate of change, or the slope, which is y2 minus y1 over x2 minus x1. And the b represents the y-intercept. So we've been talking about that for the past 2 lessons. So we're going to be building on that knowledge today to do our lesson, which is to find equations. So let's go ahead and do this. How to write a linear function equation if you're given points and or a slope. The first step is you want to find the slope. Now, if you get lucky, you might get an easy one where they just tell you the slope off the bat. But if they don't, you're going to have to use your slope formula to calculate the slope. Okay? But you do need to find your slope. The next thing you need to do is you need to find your y-intercept. So to do that, you're going to use the equation y equals mx plus b. You're going to plug in everything that you do know. As you guys know, let me write out the equation here really quick. The b represents the y-intercept, right? And that's what we want to find. So if I want to find b, then that means if I plug in something for x, m, and y, I can solve for b and find my y-intercept. And that's exactly what we're going to do. So to find your y-intercept, you're going to plug in your slope and an x value and a y value to find your missing b value. Once you have your slope and your b value, you should be able to write your equation. Okay, so let's go ahead and jump in here. So example 1a. In this problem, I'm telling you the slope, and I give you this point, 1, 5. So that's an x value and a y value. Now, as I told you guys, you need to start by identifying your slope. So step 1, let's identify our slope. Well, luckily, this is an easy problem. They're just telling us the slope is -3. So I'm just going to write that down here. The slope is -3. Now, number 2, we need to find our y-intercept. And this is where most of our work is going to be at for this particular problem. To find your y-intercept, you're going to take the slope-intercept equation, y equals mx plus b, and you're going to plug in something for y, m, and x so that you can find b. Well, we have all those things. My m is -3, my x is 1, and my y is 5. So I'm going to replace y with 5. I'm going to replace m with -3, and I'm going to replace x with 1. And then from there, we just have to solve it. So multiplication first, -3 times 1 is -3. And then to solve for b, all you have to do is add 3 on both sides, and b will be all by itself. And so now we have the fact that b equals 8. So now we've got our y-intercept, we have our slope. You're ready for the last step, which is to write the equation. And that's really just putting the numbers that you have in their correct place. So once you have the first two, you pretty much have it. So we have y equals m, which is -3, x plus b. There's the equation of the line. So you just take your answer from part 1, your answer from part 2, and put them in the m and the b spot, and you've got your equation. So that's how you can write a linear function if you have a slope and a point. Now, for part b, I think before I do part b, I'm going to have you guys do one. So student practice. Go ahead and pause the video here and find the equation of a line that has a slope of m equals 1/2 and a point of 4/5. Pause the video here, and you'll see the solution when you're unpausing. Okay, so step 1, the slope is 1/2. Step 2, plug in your y value, which is 5, your m, which is 1/2, your x, which is 4, and leave b as b, so we can solve for it. 1/2 times 4 is 2. If you forget how to do that, just think of that as 4 over 1, right? Top times top is 4, bottom times bottom is 2. So you have 4 over 2 when you multiply it, which reduces to just 2. Then you go ahead and subtract, and you have your answer, which is 3. So y-intercept is 3, slope is half. So final answer is y equals 1/2 x plus 3. All right, let's go ahead and take a look at a different kind of example now. Let's go ahead and take a look at example 1b. In this case, I give you, instead of a point and a slope, I'm giving you 2 points. Okay? So these ones require a little bit more work. Okay? So the reason it requires a little more work is because you don't know your slope right away. So when you don't know your slope right away, because they didn't tell it to you, you have to calculate it using the slope formula, y2 minus y1 over x2 minus x1, which is something we talked about back in lesson 1.1. So if you missed that or forgot about it, you can go review that there if you need to, or look at your notes. So in this case, we have 2 points, x, y. And we'll call the first set the 1s, and we'll call the second set the 2s. And using our slope formula, then we can get our slope. So we have y2 minus y1 over x2 minus x1. And so that's going to be negative 3 over 1, which reduces simply to negative 3. Okay. Now we got to find our b. Now, from here on out, the rest of the problem is pretty much the same. We're going to do our slope-intercept formula here. We're going to plug in our y value, our x value, and our slope. But what's different here is that you have 2 x values and 2 y values. So which one do you use? Well, it doesn't really matter which one you use. So I'm going to go ahead and just use this one, the 2, 2. So I'm going to use 2 for y and 2 for x. And of course, negative 3 for my slope. So here we go. So 2 is y, negative 3 is m, x is 2. Negative 3 times 2 is negative 6. Add the 6 on both sides to solve for b. And we get 8. And some of you guys might be feeling a little insecure. It's like, well, if I use this other point, would I have gotten the same answer? And the answer is actually yes, you would have. You still would have gotten 8. So it doesn't matter which point you pick. All right, final step is to write the equation. So that would be y equals negative 3x plus 8. Okay? So let me give you guys an opportunity to practice one of those. Go ahead and pause the video here and try number 2. Okay, so I labeled my points x1, y1, x2, y2. I used my slope formula, y2 minus y1 over x2 minus x1. Did you catch the double negatives there? That actually becomes a positive 3 on the bottom then. So we have 6 divided by 3, which is 2. So my slope for this line is 2. My y-intercept, I went ahead and plugged in the negative 3, 0. So I plugged in 0 for y and negative 3 for x. And of course, I used the 2 for the slope. Solving for b, I got 6, and then the equation was 2x plus 6. All right, one other type of question I want you guys to be able to handle is, how do you find the equation if they give you a graph instead? Okay, so in this case, I'm giving you a graph. Well, basically, we need to start by finding our slope. Now, when you have a graph, you can find the slope in 2 different ways. One way is by picking 2 points, right? And knowing the coordinates of those points, 3, 1, and 6, 3. And then, of course, labeling those as x1 and y1. And x2 and y2. And then doing your slope formula. So after you pick 2 points and label them, it becomes just like the last problem. So it's 3 minus 1 over 6 minus 3. So I end up with 2 over 3. That's my slope. Now the other way you can get the slope, instead of using the formulas, you could do the other thing we talked about in lesson 1.1, which is where you just go over and up from one point to the other. And since I went to the right, that's a positive. And how far right did I go? 3. And then we went up, which is another positive, and that's, I went up 2 spaces. So my rise over run would be 2/3. So that's another way you can do it if you don't want to use a formula. All right, for part B, I want to find the y-intercept. Now, if it's a graph, sometimes you can tell just by looking at the graph where it touches the y-axis. We're not going to have that luxury here because it never quite makes it there on our picture. We don't have enough picture to see where it touches the y-axis. So we're stuck with using the older method, which is where you're just going to pick a point and a y-intercept, a point and a slope, and plug it in. So let's go ahead and go with this point right here, 3, 1. So I'm going to plug in 1 for 3. My slope is 2/3. And then I'm also going to plug in, for x, I'm going to plug in 3. All right. Oh, I screwed that up, didn't I? I shouldn't have had the x there anymore. I'm replacing x with 3. Okay. So now how do you deal with fractions? And once again, I told you, you're going to make that a fraction. You're going to multiply straight across. And you're going to get 6/3. Right? And then you're going to reduce. Now, luckily for me, 6/3 is just 2. I'll tell you what to do if you have a fraction here in a minute. But for now, just bear with me. We'll finish the problem. Go ahead and minus 2 on both sides. And we get -1. So now I've got my y-intercept, I've got my slope. We're ready for the equation. So that's going to be y equals 2/3 x minus 1. Now, let's come back to the middle here. I'm just going to make up a problem really quick. Let's keep the slope of 2/3, but I'm going to switch things up a little bit. Okay, let's say that we plugged in a different number, and I'm not even going to use this graph. I'm just going to pick something else, okay? So forget that graph even exists. So let's say I plugged in 2 for y. I'm plugging in my slope, which is 2/3. And let's say that I picked an x value of 5. Now, you don't have to write this down if you don't want to. You can just watch. But the point is, how do you deal with fractions? I'll show you. So same thing. We're just going to put this over 1. Multiply straight across, right? And you're going to get 2 equals 10/3. But here's the problem. On the last problem that we did, this reduced into a nice number. Well, there's 2 ways you can handle this. One way is you can just, get a calculator out and do 10 divided by 3 and get an estimation. Or, and this is the way I'm going to recommend to you, I don't like that 3 there. So what I'm going to do is I'm going to multiply this fraction by 3, which I'm allowed to do so long as I multiply everything else by 3 also. Okay, so by multiplying this by 3, you end up with 30/3, which is just 10. And then here we have 6. Now so that's the trick. So if you ever have a fraction you want to get rid of it, just multiply everything by the bottom number, and that will cancel the fraction out. And then from there you just solve what's left. So just a little side note, if you guys ever end up with a problem where there's a fraction that doesn't go away, that's how you'll handle it. Okay? So I worked out the rest of the problem just for the heck of it, but there it is. So, and just be aware that that problem I just did had nothing to do with example 1C. It was just to show you guys what to do if you ever end up with a fraction along the way. So here's one for you guys. Go ahead and try number 3. See if you guys can find the equation of this line. Pause the video. All right, here you go. So I went ahead and picked these 2 points, 3, 6 and 5, 2. Used my formula, got -2. Then I went ahead and plugged in this point for x and y and my slope to the y equals mx plus b formula to solve for b, and I got 12. So my equation would be y equals -2x plus 12. All right. Next thing I want to talk about is word problems. We're going to talk about 2 different kinds of word problems today. So I have example 2, and then I'll let you guys try one like that. And then example 3, it's a little bit different. And then I'll let you guys try one like that, and that will close out our lesson for the day. So let's look at two different examples here. So basically what the word problem, how you can kind of think of it is it's basically the same thing as what we did with these problems here. The only difference is that the data is hidden inside of the story, and so we have to know what our data is, and we have to pull it out and use it in the right way. So let's go ahead and read this. It says a vehicle starts with a full tank of gas. After having driven 50 miles, there's 23 gallons of gas remaining in the tank. After having driven 300 miles, there's 13 gallons remaining in the tank. Write a linear function to model this scenario using x to represent the miles driven and y to represent the gallons of gas that are left in the tank. All right, so the first thing that we're going to do is we're going to create a chart to organize our data. Remember, x represents miles driven, so I'm going to put miles above my x variable there, and y represents gas left in the tank. Okay, so now that I've got this little chart set up, what I'm going to do is I'm going to take the numbers that they gave me in this word problem and put them in the chart. So a vehicle starts with a full tank of gas. After having driven 50 miles, so I'm going to put 50 here in the miles column, there's 23 gallons remaining in the tank. So after 50 miles, there's 23 gallons remaining. After having driven 300 miles, there's 13 gallons left in the tank. Okay, well, now that I have a table here, we have enough information to turn this into a linear function equation. So we're going to follow our steps now to find the equation of this line. We need a slope, we need a y-intercept, and then once we have those two things, we can go ahead and write our equation. And that's it. Pretty straightforward. So these are my x values here, and these are my y values, right? So we'll call this first set my x1, y1. We'll call this second set here my x2, y2. So using our slope formula to find our slope, we're going to do y2 minus y1 over x2. Did I do that right? Y2, I don't think I did that right. Let me back up a little bit. I don't like what I just did. Try that again. Y2 is 13 minus y1 is 23. There we go. Over x2 minus x1. There we go. And so 13 take away 23 is negative 10. 300 take away 50 is 250. And that reduces to be negative 1/25. Okay. Now, 13 and 23, those are gas gallons, right? So those are gallons of gas. 350, those are miles. And so what this means is we have gas over miles here. So the gas in my tank is decreasing because it's negative at a rate of 1 gallon every 25 miles. Okay, so step 1, make a chart. I will tell you what the x and y is, plug your numbers into the chart. After that, just use your slope formula, and then now we're going to find the b value doing the same exact thing that we've been doing all day today. So you're going to pick a point. So let's say I choose this one. You're going to plug in your y value for that point. You're going to plug in your slope, which we just found in the m step here. You're going to plug in the miles, the x value there. And then you're going to put b there. So if I multiply 50 over 1 times negative 1 over 25, we end up with 50 over 25. And it's negative, of course. And luckily that divides nicely. So we have 50 divided by 25 is 2. That's a negative 2 because there is a negative in the front. And if I add 2 on both sides of this equation to solve for b, I get 25. So now I have a slope of negative 1/25, which means that I'm losing 1 gallon every 25 miles, and I have a y-intercept of 25. So my equation will be y equals negative 1 over 25x plus 25. Okay? All right, use your answer to find how much gas was in the tank initially. Initially is a fancy word for at the start. So at the start of our problem, we have gone 0 miles. So that means that x equals 0. So use your answer to find out how much gas was in the tank initially. That means I'm going to plug 0 in for x. So I'm going to take this equation here, y equals negative 1/25 x plus 25, and I'm going to plug 0 in for the x. Now if I do that, 0 times 1/25 is 0, so we don't really need to include it anymore. It kind of cancels out, and I'm left with 25. And that is how much gas was in the tank initially. Now I want you guys to grasp something here. On our very first lesson, lesson 1.1, you guys remember I told you that slope is rate of change, but the y-intercept, when you're doing a word problem, it usually tells you the starting amount. So the starting amount of gas is 25. And that's what I got here. The reason that's the starting amount is because the y-intercept is where x equals 0. Or in other words, when we started, that's after 0 miles have been driven. Plug that in, you get 25 gallons. So it's not surprising that our starting amount of gas was our y-intercept, because that's what I told you guys on the first day of class. All right, so let's review these steps really quick. Make a chart, find your M. I'll put C for chart. Find your M, find your B, write your equation. Remember too, I'm going to give you a value you're just going to plug in and solve. Right? Now I was also interpreting things like telling you what the slope means and what the y-intercept means, and I would encourage you to try to think about that too. Like on this problem, I was telling you that slope was gallons per mile, and the y-intercept was the starting amount of gas. So I'm going to encourage you guys to try to do that on the next one, but you don't have to do the interpretation necessarily, but it's a good thing to try. So go ahead and pause the video here and see if you guys can write the chart. I'm only going to ask you to start by writing the chart. So go ahead and write your chart. Pause the video. And here's what your chart should have looked like. Our two variables, x and y, are age and pounds. They tell us here that x is going to represent age, y is going to represent weight. So in the story problem up here, it tells us that a 2-year-old is 28 pounds and a 5-year-old is 40. So this is how you set up your chart. Now I'm going to have you guys go ahead and pause the video here and find your slope, your y-intercept, and your equation. Okay, so this is what you guys should have gotten. I'll let you guys study this a little bit. If you need time to study it, go ahead and pause the video and stare at it for a while so you can figure it out. But I end up with y equals 4x plus 8. Now the next thing I'm going to challenge you guys to do before we move on to number 2 is I want you guys to tell me what does this mean? Now, in my problem, on the last slide, I had negative 1/25, right? And I told you that that was gallons per mile. And I did that by looking at, well, what are the top numbers? What are the bottom numbers represent? And putting those together, we can figure out what this is. So what do you guys think this represents, the 4? So pause the video and think about that for a minute. And then when you unpause it, I'll share with you what it means. Okay, so the two top numbers, 40 and 28, those are pounds, right? The two bottom numbers are ages. So what we're looking at here is pounds per year. Actually, instead of putting age, I'll put year. It's a little bit easier that way. Sounds nicer. Pounds per year is what that means. So we're looking at 4 pounds per year, but notice it's a positive 4, right? So what this means is that the child's weight is increasing because it's a positive slope. It's increasing at 4 pounds every year. That's what this slope tells us. What does the y-intercept tell us? Now, we talked about what the y-intercept tells us on the last page as well. So go ahead and take a moment and think about it. What does this y-intercept tell us? When pause the video, I will tell you. Well, what I told you guys is that the y-intercept tells you the starting amount. So that means that when the child was born at year 0, the child's weight would be 8. Okay? So if you were to plug in 0 to this equation here, you would end up with 8. So that means when the child was born, the child was 8 pounds. So the slope tells you how fast the child's weight is changing. The y-intercept tells you what his weight was to begin with. All right, so all that being said, let's go ahead and move on to number 2 here. Use your function to predict the child's weight when he's 7. Now, first of all, we're talking about, is this an age or is it a weight? It's an age, right? So I'm telling you an x value. And what am I telling you x equals? X equals 7. I'm telling you the child is 7 years old. So go ahead and see if you can use this equation, knowing that x equals 7, to find the child's weight. Remember, the weight is y. So in other words, if x is 7, what's y? If the age is 7, what's the weight? Pause the video and see if you can work it out. So what you guys should have done here is, since we know that they're telling us the child's age is 7, that means x equals 7. And if x equals 7, that means I can find y by plugging in 7 for x. And y is the weight. So in other words, now I can calculate what the child's weight is. So we have y equals 28 plus 8. 28 plus 8 is 36. So the child would technically be 36 pounds at age 7 if this equation was to truly represent the child. Now, another way you guys could do this is if you know if the child's weight starts at 8 pounds and every year he puts on 4 pounds, well, 7 years, 7 times 4 is 28, plus the starting weight of 8 gives you 36. So you can just kind of do it intellectually that way as well. All right. Now, that's one type of question. So before we move on to the next type of question, I want to show you guys what this one was. This is a type of question where you're going to use a chart. And how do you know you're going to use a chart? Because I give you 4 numbers. I give you 2 sets of gallons, and I give you 2 sets of miles. You have 4 numbers there. Okay? So 1, 2, 3, 4. And then from there, you're going to solve it exactly the way we did here. Okay? The next problem I'm going to give you, you're going to notice the difference is that I don't give you 4 numbers, I only give you 3. Read it. We have 1 number here and 2 numbers here. And it's a different kind of word problem, and you'll see why as we go along. But here's how you can really tell the 2 word problems that I'm going to ask of you guys to do apart. One type will have 4 numbers, the other one's going to have 3, and that's how you can tell which one is which. All right, but let's go ahead and read it here. It says, the average American spends $140 per day. On the 12th day of the month, a person who spends this much per day still has this much money left in the bank. So the first thing they're asking is to write a linear function. They want x to represent the days of the month, and they want y to represent money that's left in the bank. Okay. Now, for these ones, we only have one x value and one y value. They tell us that x represents the month, and they tell us that y represents the money that's left in their bank account. Okay, so they tell us that on the 12th day, they have $3,320 left in their bank. Okay, but that's all they give us for an x value and a y value. This is not an x value or a y value. Now, there's a very important word here that's different. It's per. When you see that, it could also be something like every, but what we really have is we have 2 variables. We have money and a day. We have dollars per day. Dollars per day. When you have $1 per day, you have a slope or a rate of change. So for the problems where they give you 3 numbers, one number is going to be an x, one number is going to be a y, but the third number is going to be a slope. So it's $140 per day. So this person is spending $140 every day, and that's our slope. So let's write that. M equals 140. And the way that I know that's my slope is because of this word per. Or it could also say every, $140 every day. So we have an x, we have a y, we have a slope. Well, we know how to find an equation when we have a slope, an x, and a y. What we do is, first of all, you identify your slope, which is 140. We already know that. But here's something that's kind of not obvious, is would you say that this person is gaining money or losing money? Read the problem. It says they're spending money, right? Since they're spending money, that means they are losing money. So our slope is actually negative 140. The amount of money in their bank account is decreasing by $140 every day. So the slope is actually negative $140 per day. So you got to be careful with that. That's the one trick with these three number problems, is that when they tell you the slope right off the bat, you have to think, is this an increasing function or a decreasing function? In other words, is my slope positive or negative? All right, now we go ahead and we move on to the B part. So we're going to plug in the y value that they gave us. We're going to plug in the slope that they gave us. And the x value that they gave us. And we're going to go ahead and solve it from there. So 140 times 12. Well, I'm going to use my calculator here. I don't have the brain power to do that. Let's see. 1680. So we're looking at negative 168. So that's 12 days, right? Spending $140 every day. So 140 times 12 is we spent a total of 1680. And that leaves us with this much money in the bank. So if I want to solve for B, which is my y-intercept, my starting amount, we just add this back over here to this side. And we get our final answer. B equals 0, 0, 0, 5,000. So this person's spending $140 a day. Y-intercept is 5,000. So we have an equation of y equals negative 140 x plus 5,000. Number 2, how much money does this person have at the beginning of the month? Well, at the beginning of the month, I guess I should have put days here, huh? Because x represents days of the month. It's not the month itself. So this is the 12th day. So at the beginning of the month, that means at 0 days, how much money do you have? Well, if I plug in 0 here, that's just going to cancel the 140 out and be left with 5,000. So the answer to this last thing here is 5,000. But we also could have known that because, as you guys know, the y-intercept just represents the starting amount anyway. So my equation is negative 140x plus 5,000. The starting amount was 5,000. And the slope is, as you guys know, $140 a day. All right, so let's review really quick. You can still make a chart if you want to identify your x and y. But the third number is going to be your slope, and you have to be careful about whether it's positive or negative. You have to read the problem to ask yourself, is this an increasing function or a decreasing function? You can tell by reading the problem. After that, do your 3-step process for writing the equation. Slope, intercept, equation. Number 2, they're going to give you a number to plug in, and you're going to find the other one, basically. All right, so let's go ahead and have you guys do this. The first thing I want you guys to do is I want you to set up a chart. And I want you to find out which one's your x, which one's your y, and which one's your slope. So pause the video here and give it a shot. So in this problem, the x represents months. Okay, so the only month they gave me is 2 months. That's right here, so we have 2. And the y value represents the percentage. So at 2 months, he has 73% left. Now you guys might have thought, wait a minute, isn't this a percentage? Well, yes and no. This is the other number. This is our slope. How do I know this is the slope? Because of that word per, or it could be every. 5% per month. So my slope is 5. But is it positive or negative? It says a student who wants to improve his grade is trying to improve by 5% per month. So if his grade is improving at 5% per month, would that be plus or minus? Well, that's going to be a plus. It's a positive. That's going to be a positive 5 because his grade is improving. Okay. Now go ahead and pause the video and find your equation using the three-step process. So our slope is 5. The y-intercept, I plugged in 73 for y, plugged in 2 for x, and 5 for m, solved for b, and I get 63. Now, the m, as you guys know, represents how much of an percentage increase the student wants every month. So 5% per month. The b, as I told you guys, represents a starting amount. So apparently this student's grade at the beginning of the story was 63%, and he wants to go up 5% per month. All right, number 2. The student's been working on improving his grade for 6 months. What is his grade? So my first question to you is this 6 months, is that an x value or a y value? Well, x represents months, so this is an x value. So x equals 6. They want to know what's his grade. Is that an x value or y value? Well, y is the percentage, right? So that's his grade, so that's a y value. So they're asking, what is y? So if x is 6, what is y? We're going to plug it into our equation to get the answer to that. So y equals 5, and I'm going to plug in 6 for x. So 5% per month for 6 months is a total increase of 30, plus a starting amount, which is 63, is 93. So if the kid could actually keep up that pace, after half a year, he would have an A. Okay, so there you guys have it. So those are the 2 types of word problems I'm going to ask you guys to do for linear functions and writing equations. They'll be the ones with 3 numbers. Those are the ones where you have an x value, a y value, and a slope. But there's also going to be the ones that have 4 numbers. Those are 2 x's and 2 y's. Those ones require a little bit more work because you have to actually calculate the slope. But that does it for that lesson. Go ahead and do your homework for lesson 3. Have it ready before our next class, and I'll see you guys then.